This video is about astigmatism, the sine square formula. So here you can see that I have an optical course. At the 15th degree axis, this meridian has a power of -3, and at the 105 meridian, this has a power of plano, 0. Now you can calculate the power of each individual meridian. So let's say I want to know the power of the 180 degree meridian right here. So this meridian is at 180. So I want to know the power of this meridian. What is the power of this meridian? And there's a way to calculate this. It's called the sine square formula, which is this right here. So F is the power at the 180 degree meridian. F cil is the power of the cylinder, which in this case is -3. Sine square of theta. Theta is the angle from the meridian in question to the cylinder meridian, which is the plano meridian. So again, the theta is the angle from the meridian in question to the plano meridian. It has to be a plano meridian here. So this angle right here is theta. So let's go ahead and calculate the power of the 180 degree meridian. So let's do that. Let's go ahead and plug it in. So the power of the 180 degree meridian, F, is equal to -3 times sine of theta, which is again this angle right here, which turns out to be 75 degrees. So it'll be sine of 75 degrees squared. So if you plug this into your calculator, you get F equals minus 2.80 diopters. And that's it. There you have it. So you can calculate the power of the 180 degree meridian, and the power would be minus 2.80 diopters. Notice that since this meridian here, the 180 degree meridian, is closer to -3, then the value of this meridian is closer to -3. So let's say if I want to figure out the meridian of the 90 degrees, the 90th meridian, so that value will be closer to 0. So from here, there's a gradual change from here from 0 all the way to -3. And you can calculate each power of each individual meridian using the sine square rule. Again, with the sine square rule, the theta has to be always from the plano meridian. So what happens if you have another example like this, where there is no plano meridian? So in this case, you have to separate the components. You have to separate the optical course into a sphere component and a cylinder component. And I made a video on how to separate an optical course from the sphere component and the cylinder component. So you can click on the link in the upper right side of this video, and I'll show you how to separate the optical course from a sphere and a cylinder component. So in this case, you take the most positive. In this case, you take the +2 and you draw out the meridian. This is the sphere component because it's the same power in both meridians. And then you figure out the cylinder component, which is you have to think about it as an algebra. You think about it as an algebra problem where you have to add this meridian, this optical course, to give you this here. So 2 plus what equals 2? That's really simple, right? Just plain. 2 plus what equals minus 2? That will be minus 4. Minus 4 over here. So there you have it. There you have the spherical component over here and the cylinder component over here. So let's say I ask you, what is the power of the 25 meridian? Let's say the 25 meridian is right here. This is the 25th meridian. What is the power of the 25th meridian? So again, you use the sine square formula. So let's go over here. You do F equals F sil times sine squared times sine square of theta. So theta is always from the plano meridian. So in this case, since you already separated the two optical crosses, the plano meridian is right over here. This is the plano meridian. So you want to find out the power of the 25th meridian. So the 25th meridian is right over here, 25. So that means that this angle is 65 degrees. So if you plug into the formula, F equals F sil, which is minus 4, that's the cylinder, minus 4, times sine square of theta. Sine square of theta, and theta is 65. So you plug this into your calculator and you get F equals minus 3.29. Now you're not finished yet. You're not finished yet because that's the power of this meridian right here. That's the power of the cylinder component of the optical cross. So this is the power right here, the 25th meridian. So you have to add it to this meridian here, the 25th meridian of the sphere component right here, which is, what is that? The 25th meridian of the sphere component is just a plus 2 because this is the sphere component. The sphere component, all of the meridians are the same. So the 25th meridian here is plus 2. So it will be plus 2 plus minus, I have here minus 3.29 because this 25th meridian has a power of minus 3.29 diopters. So to find out the power of this meridian right here, you have to add the two components. So it will be just simply plus 2 plus minus 3.29, and let me go down a little bit. So the final answer, if you just plug this into your calculator and do this in your head, you get minus 1.29 diopters. So that's your final answer. So the 25th meridian right here is minus 1.29 diopters. And then you can check yourself. You can see that this meridian right here is closer to minus 2, so then the number should be closer to minus 2 than to plus 2. If I asked you to find out the meridian of the 80th degree meridian, the power of the 80th degree meridian, then that value would be closer to plus 2. Okay? Hopefully that helps.